You're watching a horror movie, and right as the music swells, you feel it. Every hair on your arm stands straight up. Tiny bumps rise across your skin. For a split second, your body is doing something it hasn't needed to do in over 1,000,000 years. It's trying to fluff up fur you don't have anymore. So why is this ancient reflex still firing every single time on a body that lost the fur that used to make it useful? Let's start with the mechanism itself, because it's more precise than most people realize. At the base of every hair follicle on your body sits a tiny muscle called the arrector pili, Latin for the muscle that raises the hair. There's roughly one attached to nearly every hair follicle you have, everywhere except a few specific hairless patches, like your palms, the soles of your feet, and your face. Which is exactly why you'll never see goosebumps rise on your palm, no matter how cold or frightened you get. When your sympathetic nervous system, the same system responsible for your fight or flight response, gets triggered by cold or fear, it releases a chemical messenger called norepinephrine. That chemical tells the arrector pili to contract, and the contraction yanks the hair follicle upright, which is also what physically pinches the surrounding skin into the small raised bump you actually see and feel. On an animal covered in thick fur, that single motion traps a layer of warm air against the skin, doubling as insulation, and simultaneously makes the animal's outline look bigger and more threatening to a predator. Two survival functions, running off one tiny muscle, in a single automatic motion, controlled by a part of your nervous system you have no conscious access to at all. Here's the mismatch. Somewhere between 1 and 2 million years ago, your ancestors' bodies started losing the thick coat of fur that made this reflex actually useful. The leading theory involves early humans becoming increasingly active, long-distance hunters in hot climates, and losing dense body hair let sweat evaporate off bare skin far more efficiently, which is a much better cooling system for an animal that runs prey down over hours instead of ambushing it in a single burst. Humans have somewhere around 2 to 5 million sweat glands, far more than almost any other mammal, and bare skin lets that sweat actually evaporate and cool the body instead of getting trapped and matted down in fur the way it would on a chimpanzee or a wolf. It was, evolutionarily speaking, a very good trade, one that let early humans outlast prey animals on the open savanna simply by chasing them until their bodies overheated and gave out. But evolution rarely deletes old hardware just because the environment that once needed it disappeared. The arrector pili muscle stayed. The nerve pathway that activates them stayed. What vanished was only the fur they were built to move. You're left with the reflex minus the actual coat. Charles Darwin himself noticed this exact contradiction all the way back in 1872. And pointed to human goosebumps as living evidence of our shared ancestry with furrier mammals. He wasn't wrong. Look at almost any animal with a genuine coat, a frightened cat arching its back with every hair standing on end, a porcupine raising its quills, a startled dog's hackles rising along its spine. And you're looking at the exact same arrector pili mechanism your body still runs, just attached to hair that's actually still there to matter, still doing the job it evolved to do. So does that make Goosebumps completely pointless? Just a leftover glitch with nothing to show for itself? The biological equivalent of a light switch wired to a bulb that got removed years ago? For a long time, biologists mostly assumed exactly that. But in 2020, a research team led by Yachia Hu at Harvard, working with Sungjan Lin at National Taiwan University, published a study in the journal Cell that complicated the story. Using mice, the researchers discovered that the arrector pili muscle isn't just a mechanical lever for raising hair. It also physically anchors the nerve fibers that connect to hair follicle stem cells, the very cells responsible for growing new hair. Under high-resolution electron microscopy, the team found these nerve fibers wrapped around the stem cells almost like a ribbon, forming a direct synapse-like connection. The kind of tight signaling relationship you'd normally expect between two nerve cells, not between a nerve and a stem cell tucked inside skin tissue. As Xu put it afterward, the team was genuinely surprised, since neurons don't typically target epithelial stem cells that directly. When the mice were exposed to prolonged cold, The same norepinephrine signal that triggers the immediate goosebump response also nudged those stem cells out of a resting state and into action. And within about 2 weeks, the cold-exposed mice had grown noticeably thicker fur than mice kept at normal room temperature. In other words, in mice at least, goosebumps aren't just a dead-end reflex. They may be the fast, short-term half of a two-part system. With a slower, long-term instruction buried in the exact same signal, raise the hair now and start growing more of it for later. Whether that same long-term stem cell response still functions in modern humans hasn't been confirmed the way it has in mice. But the underlying wiring, the muscle, the nerve, and the hair follicle working as one connected unit is highly conserved across mammals, humans included. That still doesn't explain the version of goosebumps that has nothing to do with temperature at all. Why does a piece of music, a wave of nostalgia, or a genuinely moving scene in a film trigger the exact same physical reflex as standing outside in the cold? The mechanism is identical. It's still the sympathetic nervous system, still norepinephrine, still the arrector pili contracting on command. What's different is the trigger. Neuroscientists believe emotional goosebumps piggyback on the same ancient alarm system, borrowed and repurposed by the brain's limbic system, which governs emotion whenever it registers something as unusually significant. This specific sensation even has its own name in psychology research, frisson, from the French word for a shiver, used to describe that skin-prickling chill people get from music, art, or an emotionally overwhelming moment. Studies on frisson have found it tends to peak at unexpected musical shifts, a sudden key change, a swelling chord, a voice breaking with emotion. Moments the brain flags as surprising or emotionally significant in real time. Your brain didn't evolve a separate reflex for chills down your spine during a song. It simply reused the wiring that was already sitting there. Built originally for a fur coat that hasn't existed in over 1,000,000 years, and repointed it at anything that feels emotionally intense enough to matter. So put it together. Goosebumps survive for the same reason so many other ancient reflexes survive inside a modern body. Evolution is a renovator, not a demolition crew. It rarely rips out old wiring just because the room it once served got remodeled. The arrector pili muscle, the nerve pathway feeding it, the whole tripart system of muscle, nerve, and follicle cost the body very little to keep running. So there was never much evolutionary pressure to shut it down completely, even once the fur it was built to move had disappeared. Biologists call structures like this vestigial, the same category that includes your appendix and your wisdom teeth, remnants of a body plan your species has since moved past. But vestigial doesn't automatically mean useless. And in at least one documented case, in mice, that old system turned out to still be doing quiet, useful work in the background, tying skin's short-term reflex to its long-term hair growth, long after its original headline function stopped mattering. Every time you feel that specific prickle, whether it's a cold wind, a horror movie, or a song that catches you off guard, you're watching a genuinely ancient piece of machinery fire exactly as designed, tens of thousands of generations after it first evolved. It's just aimed at a body that stopped needing what it was built for well over 1,000,000 years ago, still faithfully trying to fluff up a coat that's been gone since long before anyone alive today, or anyone who has ever lived and walked upright on 2 legs, was ever born.